Hi everyone, my name is Shihui Song. Today I will give you a speech about our paper Rumor Detection on Social Media without Integrated Graph Convolutional Networks. The authors of this paper include Yaben Huang, Hongwei Lu, and me. Now I'm a PhD student at the University of Iowa. So if you have any questions about our paper, please contact me with this email. So I will introduce our work from the following four parts: backgrounds, related work, model, and the experiment. So let's start with the background. Our paper mainly focuses on rumor detection on social media. So what is rumor and why we need rumor detection? Actually, we can easily regard rumor as misinformation or disinformation that circulates from person to person. And there are three reasons for us to detect rumor. The first one is the user number is enormous. With the development of online social network applications and platforms, more and more users obtain information on these platforms, such as Sina Weibo, Twitter, Facebook, and Instagram. For example, according to the 2020 Weibo User Development Report, the monthly live users of Weibo is in September 2020 reached 500 million. The second reason is rumors spreading fast through social media platforms. For example, during the epidemic period in 2020, more than 8,000 rumors were officially marked and disposed by Sina Weibo. The last one, the spread of rumors will have many negative effects, like there are some effects on the election. So it's meaningful to detect rumors automatically. So why we use graph neural network? This is an example of social network. In rumor detection, every post in the event can be regarded as a node in the graph. The information contained in the social network itself is complex. In order to detect rumors, the most effective method is use a graph neural network model. So through aggregation of neighbors nodes, a graph neural network can enhance the representation of graph structure. For example, if we want to represent these red nodes, we can aggregate the information from these three red nodes and these blue nodes. Since graph data is classic non-Euclidean data compared with the traditional deep learning model, the key feature of graph neural network is that it can process non-Euclidean data and effectively represent node characteristics. Well, in this part, I will show you three methods for rumor detection, and I will explain our motivation and goal. Most previous known graph methods can be divided to statistic learning method and deep learning methods. Most statistic learning methods focus on manually fine-grained feature engineering, so it's labor intensive and not practical. Deep learning models could capture features of content effectively, but they ignore the total social network structure and the propagation structure, so they led to low accuracy. Graph neural network methods could capture graph structure information better, so it's a good idea to use a graph neural network. Though having taken graph structure features into account, we argue that the existing GNN-based method ignore the position contributions of nodes and cannot effectively efficiently process the imbalanced data. Here comes our goal. We aim to process a model accurate and flexible, and we want to propose a more accurate and flexible rumor detection model based on graph neural network. So in this section, I will introduce our OID GCN model to you detailedly. This is the this model called out-in degree GCN, and there are mainly four parts. The out-in degree graph parts, cards centrality parts, the GCN parts, and finally the four connected parts. We regard each forwarded rumors as nodes in this rumor propagation network. At first, we divide the rumor propagation network into two graphs, an in degree graph and an out degree graph. Then CAS centrality computes the relative influence of a node. Combine these information, let every graph be an input of a GCN, and we can get the these two output separately. Finally, we use a weighted concatenation operation to get our overall semantic vector. We define beta as a hyperparameter. I will discuss the influence of this parameter later, and we can obtain the predicted result by ReLU function and the softmax function. Then we can get the predicted result. So here are the results of our paper. Twitter 15 and Twitter 16 are the two datasets we use to evaluate our model. The statistic information is shown in this picture. They contain both rumor textual information and are well-structured rumor propagation networks, so we choose these two. And they are labeled in four categories. We can see they are true rumors, false rumors, verified rumors, and non-rumors. We evaluate the model from two aspects: accuracy performance and flexibility performance. For accuracy performance, we choose 9 updated model for comparison, and we use accuracy and F1 score for each class and to evaluate the performance of this model. And the results shows that our models perform the best both on Twitter 15 and Twitter 16. We can see the accuracy the highest. So in order to further explore the influence of beta, we perform some supplementary experiment with beta from 0.9 to 0.1. The results are shown in these pictures. We can see almost every category achieves the highest accuracy with beta 0.7, either on Twitter 15 and Twitter 16. We can see the beta is almost 0.7. So due to the design of beta, our model has a superb flexibility, which means it can generalize to different datasets. We firstly reverse 50% of edges of original dataset and construct two neural datasets called R Twitter 15 and R Twitter 16. Then run our model use these two new datasets, and the results are shown in these two pictures. Yeah, the result as we expected. The model performs the best when beta equals the 0.3. Plus, in order to show our model's flexibility, we also apply the two new datasets to other graph-based model like the TL-GSIN and BiGSIN. As shown in this table, our OID GSIN significantly outperforms the state-of-the-art method BiGSIN, and on every evaluation metrics, um, since this TL-GSIN does not have any bias to graph structure and node features, the results of the TL-GSIN are similar to before, and our model performs the best whenever the result is Twitter 15 or R Twitter 15. Okay, that's all I would like to show you. If you have any questions or suggestions, please do not hesitate to contact me. Thanks for your listening.